You are tuned to Iri-e-learning, and I am your host, Teacher. In this structure and bonding lesson, we will look at the formation of ionic bonds, which is also called electrovalent bonds. Check the description box for links to all the videos associated with this unit. By the end of this lesson, we should be able to explain the formation of ionic bonds. For any of the lessons in this unit, it would be good for you to review the Unit 2 lesson on diagrammatic representation of atoms. You may find the link below. In this section, we will identify the type of atoms involved in ionic bonds and discuss how ionic bonds are formed. What type of atoms form ionic bonds? There are two types of atoms involved in an ionic bond, a metal and a non-metal. Ionic bonds occur between metal atoms and non-metal atoms. So what happens during the formation of an ionic bond? Ionic bonds involve the transfer of the outer electrons from the metal to the outer shell of the nonmetal. When this is complete, the atoms will achieve a stable electron configuration. In other words, after the transfer of the electrons from the metal atom to the nonmetal atom, all the shells of the atoms involved in the ionic bond will contain the maximum number of electrons. You may recall from the previous lesson in this unit that we identify metal and nonmetal atoms by the number of electrons on their last or valence shell. Metal atoms, of course, will have 1, 2, or 3 electrons on their last shell. An exception to that is hydrogen and helium, hydrogen having 1 electron on its last shell and helium having 2. But for both atoms in this exception, they have only 1 shell. So we can consider that atoms that have only 1 shell are always nonmetals. And we identify the nonmetal atoms as the atoms that have greater than 3 electrons on their last shell. And as we just discussed, the atoms that have only 1 shell are always nonmetals, namely hydrogen and helium. As noted earlier in the lesson, an ionic bond is formed between a metal and a nonmetal atom. An ionic bond starts with the metal atom losing or donating its valence or outer shell electron or electrons to a nonmetal atom. The nonmetal atom accepts the electron onto its outer shell. When the metal atom loses its valence electron or electrons, it is no longer an atom but an ion. An atom that loses electrons forms a positively charged ion called a cation. The atom gains 1 positive charge represented by a plus sign for each electron it loses or donates to the nonmetal atom. This metal atom lost or donated only 1 electron as we saw in the transfer. Therefore, the metal ion or cation has a single positive charge represented by the plus sign. If the atom had lost 2 electrons from its valence shell, then the charge would have been 2+, written the numeral 2 followed by the plus sign. After the metal atom loses the valence electron or electrons, the remaining shells contain their maximum number of electrons, giving it a stable electron configuration. This metal ion has 1 shell remaining, which contains the maximum of 2 electrons. When the nonmetal atom accepts electrons or an electron onto its outer shell, it is no longer an atom but an ion. An atom that gains electrons forms a negatively charged ion called an anion. The nonmetal atom gets 1 negative charge represented by a minus sign for each electron it gains. This nonmetal atom that we started off with gained 1 electron from the metal atom. Therefore, the anion has a single negative charge. Note that the nonmetal atom only accepts the number of electrons needed on the last shell to obtain a stable electron configuration. That is, that last shell must contain its maximum number of electrons. Now, for this nonmetal atom, there were 7 electrons on the last shell, which is its second shell. Therefore, it required only 1 more electron to make 8. And as a result, it accepts only 1 electron to complete the 8 on that second shell. And of course, the first shell has its maximum of 2 electrons. As a result, the nonmetal ion now has a stable electron configuration. The ionic bond is formed when the oppositely charged ions, that is the cation and the anion, attract each other. The general rule is that opposite charges attract, and the attraction between these oppositely charged ions is called electrostatic force of attraction. Therefore, the metal and nonmetal ions involved in an ionic bond are held together by an electrostatic force of attraction. Keep note the following points. An atom that has a charge, whether that is a positive or a negative charge, is called an ion, I-O-N. However, there are specific names for positively and negatively charged ions. A positively charged ion is called a cation, and a negatively charged ion is called an anion. Also, atoms that lose electrons get 1 positive charge for each electron lost. According to the number of electrons lost, the cations would be represented as M positive after losing 1 electron, M2 positive after losing 2 electrons, and M3 positive after losing 3 electrons. Here, M represents the chemical symbol for any atom that loses electrons to become stable. In ionic bonding, that would be the metal. On the other hand, atoms that gain electrons obtain 1 negative charge for each electron gained or accepted. According to the number of electrons gained, the anion is represented as D negative after gaining or accepting 1 electron, D2 negative after gaining 2 electrons, and D3 negative after accepting 3 electrons. Here, the letter D would represent the symbol of any atom that gains electrons to become stable. In an ionic bond, that would be the nonmetal. Here are the lesson summary points. Ionic bonds occur between metal and nonmetal atoms. Ionic bonds involve the transfer of valence electrons from a metal atom to the outer shell of a nonmetal atom. Atoms gain a stable electron configuration after bonding. Metal atoms have 1, 2, or 3 electrons on their valence shell. Nonmetal atoms have 4 or more electrons on the valence shell except for hydrogen and helium. Metal atoms form cations when they lose their valence electrons. A metal atom gains 1 positive charge for each electron lost. Nonmetal atoms form anions when valence electrons are gained. A nonmetal atom obtains 1 negative charge for each electron gained. The nonmetal atom only accepts the number of electrons needed to become stable. Metal atoms donate or lose all their valence electrons to become stable. It's quiz time. You have 5 seconds to answer each question after it is read aloud. Question 1. True or false? An ionic bond is formed between a metal and a nonmetal. The answer is true. Question 2. True or false? Ionic bonds involve the transfer of valence electrons from a nonmetal atom to the outer shell of a metal atom. The answer is false. Just remember, ionic bonds involve the transfer of valence electrons from the metal to the valence shell or the outer shell of the non-metal atom. Question 3. True or false? The atom to the right is a metal. The answer is false. Remember, metals have only 1, 2, or 3 electrons on their outer shell. This atom has 8 electrons on its outer shell. Therefore, having greater than 3 electrons on the outer shell, it is classified as a nonmetal. Question 4. Which statement is correct about an ionic bond? A. Ionic bonds occur between metal and nonmetal atoms. B. Metal atoms transfer valence electrons to the outer shell of the nonmetal atom. C. The nonmetal involved in an ionic bond only accepts the number of electrons needed to become stable. D. All of the above. The answer is D. All of the above statements are correct about an ionic bond. Question 5. Aluminium, chemical symbol Al, is a metal atom that has 3 electrons on the last shell. What charge will the aluminium cation have after it is involved in ionic bonding? A. Al3 negative, B. Al positive, C. Al2 positive, D. Al3 positive. The answer is D, Al3 positive. Recall that an atom will lose all its valence electrons in order to obtain its stable electron configuration during ionic bonding. Since aluminium has 3 electrons on the last shell, it will lose all 3 electrons and the atom gains 1 positive charge for each electron lost. Therefore, aluminium will lose 3 electrons and hence a charge of 3 positive. We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with Iri-e-learning.